Hello guys, welcome to another video. This is a continuation of generics series and I will leave you in the description part 1 of part 2 if you haven't seen it yet. Today we will talk about where clauses. They are really powerful to constrain your generics to specific domains. We will see that in action. And at the end I have a challenge for you, but let's see more in a moment. My name is Pete and this is If and Tips. What are where clauses? Well, with where clauses, we can define additional requirements for our type parameters in generic context. This could be used in functions, in types, and of course, associated types. Let's see an example and why we need where clauses. Based in a stack object, let's create a method to insert directly in a kind of wrapper function. As we saw earlier, we cannot pass directly a stack, so what we have to do is actually create a generic constraint for our stack. Let's create a container type and use the constraint to be stack. Then we can use our container. There you go. Now let's call in this implementation container.push. And we will set just one for now. Look at this. We have an issue here. Cannot convert value of type int to expected argument container element. This is interesting. Let's see if we can use a fix. Okay, the suggestion, well, I already talked about this, but forcing a cast is not good normally. Okay, so yeah, this is not actually a great idea. Yeah, the thing here is that, again, we have our stack and the associated type element, and we don't know nothing about that. We haven't established a communication with Swift to say, hey, this stack will use an element of type whatever, int in this case. How we can do that? Well, thankfully, we have where clauses. With where clauses, the only thing to do is at the end, in this case, at the end of this function, we can use where, and then we need to call container, which is the actual type, generic type we are using. But since that container is a stack, we can call container.element, and then we can restrict that this element type should be int. Now we find another issue here. This is not related about generics, but is related that this container is an immutable value. So to fix this, let's use inout. If you don't know about inout, just in short words, it's basically a way to send a value type as a reference. What I mean is that you share the address of the value type instead of the actual value. So yeah, in that way you can modify internally a value type that is outside of this context. As you can see, with where clauses, it's really easy to add additional requirements for our associated type in this case. Without this, basically, it will be impossible to specify something like this, because we need to provide additional information for the compiler. Now, before we move on, let's transform this in an actual method. And instead of setting always 1, let's pass a value. But even better, let's transform this in a generic function. Let's do that. Since that we will talk about a generic value, then we need to specify a generic value here. Then we need to pass a value that is type value. We don't know that at this moment. And finally, we need also to, instead of saying that element is int, well, in this case, element will be value. What value? We don't care. That will be fixed by the concrete implementation. There you go. Let's try this. To pass the reference of a value type, the only thing we need to do is just using this ampersand operator and then send our object. In this case, let's use stack2 and pass a value. Let's use 10. Now let's print our result. Cool, as you can see, we just inserted value number 10 and we also got that value immediately. Let's do that, but now for a string. Yeah, we got also number 10 here. This is awesome, and this is the power of where clauses. So far, we have seen that we can create protocols with associated type, generics, etc. But what will happen if we want a specific subset to be doing some activities in our generic type, but also keep other kind of code in our same generic type, but for other subset? Well, for that, there is something called contextual where clauses. Let's see that. For that, as you may see in the text, we will use extensions to divide their responsibilities. Let's create a method first to check if we are putting a specific value at the top of the stack. For that, we will extend my stack structure. And let's create a function isOnTop. Let's pass a value here. It will be the value that we will ask if it's on the top or not. And again, extension contains information about what is the actual generic type we're using. And if that value is at the top, we will return a boolean, true or false. Now, to figure out what is the first value at the top, let's use values.last. But since that this is an optional, let's use a guardlet. And if we got a nil value, we will return a false. Now, the only thing to do is return if value is equal to last. And that's it. Oh, but we got an error here. Yeah, we are trying to compare two values, but we don't know if element is conforming equatable, and we require that. So, in order to explain this to Swift, we need to also specify that element should conform equatable. So, to do that, it's really simple. After the declaration of the extension, we need to use where, and then use element, and then restrict element to be equatable. That's it. It's the only requirement now here. So yeah, you can use where in this way too. It's not only for functions. You can use it as your type declaration, but also has your extension declaration. This is really convenient. So yeah, if something is not equatable, we cannot see this on top method. Let's try that. There you go. We just tried to figure out if 10 or hello are on the top, and we got false, but we find out that everybody is on top. So if we go back to our declaration, we have here that the last element inserted was everybody. Well, actually was 10, but since that we pop it, yeah, we got at the end everybody. And yeah, the result is here. Okay, but now what will happen if I want to specify something particular or very specific for the case of ints? Let's create an average method to get, of course, the average of the whole stack. But this is only specific for int values in this particular example. Let's see that. Let's specify that this extension will be only valid for ints, because we will establish that element will be only for ints. Then let's create our function average, and we will return a double at the end. Let's initialize a variable that will contain the final sum, and let's loop through the whole stack and get all the values. let's cast this to double because I will divide at the end sum. So yeah, if I do this only with ints, I will lose precision. So yeah, that's why I'm casting to double. And at the end, return the sum divided by double values.count, which is the actual number of items in the array, or in the stack, sorry. There you go. Now, this is the magic. If I want to print the average from my stack, let's use this here, stack 2, I got access to average. But if I do the same for stack 3, which is a stack of strings, I cannot see nothing. I can see it's on top, yeah? Also, stack 2 can see that. But in this case, I cannot see it because element is not an int, it's a string. Extensions in this way help you to restrict and isolate dedicated functions or implementations for your logic. This is awesome, and you can still use in generics, but in cases like this, when you want to specify that a subset or a concrete type should do something really specific, then you can apply this. This is really cool. And yeah, it's all around Swift. Yeah, using this kind of implementations with word clauses. Finally, let's try this. Number 5 is the result. Cool. Finally, I have a challenge for you. What I want is to create a function that, based on 2 stacks, merge them into one. And what I mean is that get all the values from stack 1 and then stack 2 and then create a new one and return it as a single stack. And remember, what we want to return is a new stack based on the 2 parameters provided. I will give you a moment just to pause the video, and if you want to try it, let's go.
A few moments later.
Alright, let's create this merge function. Alright, as I mentioned earlier, what I want is to pass 2 stacks in the parameter and then return a new one and combine both stacks in just one. We already saw that we cannot use stack 1 in this case, right? Yes, this is not possible. So what we need to do is then create a type parameter. Actually, 2 type parameters. For that, let's call the first type container 1 and then the other container 2. Both will be restricted to be stack. And then let's replace this with C1 because it's a container 1, and then C2 to be container 2. Let's remove the argument label in this case. Cool, now let's create the new container. In this particular case, I want to use a myStack implementation. So what I have to do is just figuring out what is the type of this myStack. And this is actually a question. What should be this type? Well, we have container 1 and container 2, but is it possible to merge both of them? It is, but only if container 1 and container 2 contains elements in the same type. Yeah. So here, if you catch that, we require another where clause to restrict that both containers should have the same element types. So to do that, we need to use a where clause here and then specify that container 1 dot element should be equal to container 2 dot element. So in this way, we are forcing that both stacks or both containers should contain the same types. That's our question. So then here in myStack, we can use any of this because both type will be the same. So we can specify that container 1 dot element is the type. There you go. Pretty cool. Okay, now let's continue. Let's insert the elements from container 1 and 2 into this new container. To do that, we will pop every stack until we got an empty stack from C1 and C2. Oh, and again, since that this is immutable, what we need to do is use in out. Okay, now let's continue with C2. Alright, we actually copy every element from C1 and C2 into our new container. This is great. Now, the only thing to do is returning the new container, right? So let's do that. We will return new container, and we need to specify here what is the return type. So yeah, let's use container. Well, container one, because yeah, both should be the same, right? Yeah, what is that? Well, we have a kind of big issue here because we just created a my stack, but we want to return a container one type. But yeah, we're not sure about how to use that. I mean, my stack and container both conforms stack protocol. But yeah, by the way, don't use this. This is not good. But if we use a stack, again, we will receive this annoying error. Okay, we have a problem here. I will give you a second chance for you to figuring out this. Pause the video just a few seconds and try to figure out how to solve this.
Eternity later.
But if you couldn't find anything, let me show you that what you can use is some stack. Whoa, what just happened here? Well, actually, we will talk more about this in the next video, but some is a new keyword provided in Swift 5.1 and is basically hiding a concrete type or concrete implementation in this case. And we only telling to Swift that the only thing we care is this return value should contain or should confirms a stack protocol, and that's it. We don't care about that. And in other words, this new container is some kind of stack, and that's it. I don't care anything about the rest. Sounds familiar? Yeah, this is the same foundation of SwiftUI, and we will talk more in the next video. But for now, let's try this. Let's create two new stacks and then merge them. Okay, we have our two stacks here, so the only thing to do is create a new one, var stack 6 equal to merge, and then send stack 4 and stack 5. Remember to use the ampersand. And what is this type? Is some stack. I don't actually care about that. So let's print this and see what is the result. There you go. This is kind of the Fibonacci sequence, and as you notice, it's working properly. We didn't have any issue with this implementation, and we learned a bit more about the use of word clauses, the type constraint with generics, and let's talk more about this some keyword. And by the way, this is something called opaque types. That's it for this video. I would like to know, what do you think about word clauses? Have you ever used this feature in your development? Let me know in the comments. Also, did you actually solve the challenge by yourself? If that's the case, congratulations. And also, I would like to know, how did you solve that? Please let me know in the comments. And one last thing, did you know about the usage of some keyword? We will talk more about in the next video. And I'm really happy because all those series of videos made possible this next video. But that's the next one. For now, I would like to thank you one more time for your support. If you enjoyed the video, don't forget to subscribe, leave your like, and that's it for now. Thank you. Have a great day.